All right, in this video, I'm going to very briefly talk about how continuity or continuous functions work with different operations. So I'm going to make sure before I get too far into this, I am going to use some examples here just to kind of help me along. And so I'm going to use these functions, f of x, g of x, and h of x. Now, h of x, hopefully you realize, is a polynomial, x plus 4. It's a linear function. Now, that is continuous between negative infinity and positive infinity. There are no restrictions to it. It is continuous literally everywhere. Now, g of x is slightly different. That is a rational function. That is one of those functions where you just can only use certain places. So what I mean by that is this. 1 over x, you cannot divide by 0, so x can't be 0. So it is continuous between negative infinity and 0 and positive infinity. Let me repeat that one more time. X can't be 0 because you can't divide by 0, and so I have to exclude it from my interval. Now, let me go ahead and do this last one up here. So, f of x equals the square root of x. Remember, that is an even radical. So, you cannot plug in a negative number here. Remember, you get imaginary numbers that way. So, I'm going to take x is greater than or equal to 0, which means that I'm going to put one bracket, 0, and then infinity. That means I can plug in any number from 0 and positive, and it's going to be continuous there, but no negative numbers. Now that I've got this information underway, let me repeat again. This is what I'm going to be looking at in a hot second. I'm going to talk about some operations that I can do and how continuity is affected. So, for instance, the first operation I'm going to talk about is what happens if I add the functions. Well, what that's going to do is that's going to maintain whatever continuity there was. So, for instance, in this case, if I were to add f of x and g of x, I'm going to add the square root of x plus 1 over x. Now, I need to worry about a couple of things. Number one, g of x said can't be 0. F of x says it has to be greater than or equal to 0. So I'm at this point right now where I have to make sure both of those things work. Let me repeat again. Can't be 0 has to be greater than or equal to 0. So what I'm going to do is I'm going to apply both parts of these. So let me repeat one more time. Has to be greater than or equal to 0, but it can't be 0. So in this case, it's going to be continuous from 0 to infinity. Let me repeat. Has to be bigger than 0. Got it. Can't be 0. Put a parenthesis, not a bracket. Got it. Now, ready for the next one? Here we go. F of x minus g of x. Guess what? That's going to be the square root of x minus 1 over x. Works the same way. Okay? So, f of x and g of x just maintain the continuity there was before. So if it was continuous here and continuous here, it's going to stay that way. All right, let me keep going. I'm going to do another one. Let's do, when I multiply it by some constant, and I'll just pick a number. I'll do h of x, okay? So that means, let me just get this out in the open. I'll use green. If I were to multiply, let's say, h of x by 3. So I'm going to take 3 times x plus 4. Here's the thing. I can simplify that and get 3x plus 4, or excuse me, 3x plus 12. My apologies. Guess what? Still a polynomial. Still continuous everywhere. So here's the thing. These functions, they maintain the continuity of their respective functions. So like I said, I used f and g, so I had to apply f and g. I used f and g here, so I had to apply f and g. If I used h here, I'm going to use whatever h was here. All right, let me do another one. Let me do, this time, I'm going to multiply f of x, and I'm going to multiply that by h of x. Okay, so here I go. I'm going to do that real fast. So I'm going to multiply the square root of x times x plus 4. What that's going to give me is x times the square root of x, or x to the third under a square root. So x cubed under the square root, plus 4 square roots of x. Now here's the thing. In this case, I have to worry about f and h. Well, h worked everywhere, but f only worked for numbers 0 and above. So that's gonna be the same thing here. It's going to be 0 and above. That's where this is continuous, okay? So, I'm going to do 2 more, but I need to erase for a second. So, here I go. Erase. The next one I need to worry about is division, all right? So, what happens if I do, and let me just do this one real fast. What happens if I take f of x divided by h of x? Now, that's going to be the tricky one. That one's going to be special, and here's why. So if I do this, I'm going to take the square root of x divided by x plus 4. Now, the thing is this, and I'm going to be very, very careful here. I have to remember what f and h are, but I'm going to have an additional one now. The additional one is that h cannot equal 0, because again, we cannot divide by 0. So here's what I'm going to do. I'm going to look at f, which said has to be 0 or above, and I'm going to also look at h. H said negative infinity, positive infinity. So any number down here worked, but I have to consider where the bottom is now can't be 0. So x plus 4 cannot equal 0, so x can't be negative 4. Well, the good thing is I don't have to do anything extra here. I would, but here's the thing. In f, we said it had to be 0 or above. Well, negative 4 is not 0 or above, so it doesn't change anything right now on this example. In the future, it will. So be careful. Always check to make sure it's not equal to 0 in the denominator. So my domain, or my continuity here, is going to be from 0 to infinity. Again, still can't be negative 4, but that's an important fact for later. All right. The last one I'm going to talk about is, what about composition? All right, so let me talk about composition. I'm going to compose g of f of x. What that means is I'm going to plug in f into g of x. That means I'm going to take g, which is 1 over x, and I'm going to plug in the square root of x. Now, here's the thing. I have to first consider what the domain of f is. The domain of f is anything 0 to infinity. Okay? That's where it's continuous, 0 to infinity. But then I have to plug that into g. So g said can't be 0. So let me make sure I check this again. It has to be greater than or equal to 0 to make the square root work, but I can't have 0 in the denominator. So again, it has to be 0 or above, but can't be 0. Okay? Square root again, 0 or above, but can't have 0 in the denominator. So that's my final answer for continuity there. Notice again, pretty much all of these have to do with the domain. That's an important fact. Again, domains and continuity are related. We talked about that in the last video. So hopefully that helps. We're going to do some examples in a little bit. But other than that, if you got questions, make sure you ask me, please.